Okay, the focus of today's lesson is flowcharting. We're getting into our programming unit, and the first half of this unit we are going to be focusing on the math logic behind computer programming, and then we'll get into some simple programming things in a few weeks. So we're starting with flowcharting because it's important to kind of map out your program and understand what exactly you are telling your program to do. So today is kind of like an introduction to that flowcharting process. So the reason I do this unit is because I think it's really important for students to learn a little bit about how computers work and things like that. So I have a statistic from the Bureau of Labor, and it says that 1.4 million new jobs will be created in computing just in this decade. And so because I'm always trying to make sure that what we do in this course is authentic and relevant to you, I think even if you aren't going to be an expert at the end of this unit, at least having a little bit of a taste of this stuff is really beneficial to you in your futures. So, like I said, we're going to focus on flowcharting today. And if you don't know what a flowchart is, it's basically a diagram that is created to illustrate the solution to some sort of problem. So for most of our cases, we are going to be creating flowcharts that are going to outline a program that we want to create to carry out some sort of function. But you may have also seen some examples like this maybe in magazines or things like that. So this is kind of a really basic example of what a flowchart is. So it's a series of decisions and functions that kind of carry out some sort of purpose. So this example is something from maybe a magazine or a poster, and it's to help you determine if you should keep an article of clothing or toss it or donate it. So as you can see, you would answer a series of questions, and depending on what your answer is to those questions, it will instruct you in what to do next. So these are the symbols that we will be using for our flowchart. So you'll become very familiar with these. This first one up here, it's an oval. Sometimes it's also represented as a rectangle with rounded sides. And this represents the start or end of the program or flowchart. So every flowchart that you create will have a start and end terminal at the beginning and end, and you'll see some examples of that. The arrows always show the relationship and kind of the flow of logic. So all of your other symbols will be connected through these arrows. There's an input and output. We'll focus on this more in a couple of weeks, but it represents any time that the program needs you to put information in or any time the program is spitting information out. Our rectangle here represents a process, so anytime any sort of process is being carried out, it will go inside this rectangle, and you'll see that in our examples. And then also, sorry, I'm trying to get my little bar out of there. This rhombus or a diamond is anytime there's a decision being made. So anytime that your program is going to kind of come to a fork in the road, if you will, and a decision has to be made, that will be represented by a rhombus. So here's a basic example, and this, I believe, is basically a flowchart that describes a situation of you basically getting home from work. So as you can see, we have our start and end terminals that are the ovals, like I mentioned, and then after we start, you have to immediately make a decision. Do you work within walking distance from home? If the answer is yes, then you'll carry out the function of walking to work, and then your arrow takes you to the end and you're done. But if your answer is no up here, and then you're asked another question, do you have a car? Yes. If so, then you carry out the function of driving to work. And then if your answer is no to that question, then you'll have to use public transportation, and then you go to the end. One important thing to remember is that this is kind of like a closed circuit, if you will. So everything should point to the end eventually. So if you answered no here, sorry, my little bar keeps coming up, then you should always have an arrow that goes to the end. It wouldn't just be over here hanging out by itself. So all things always lead to the end. Here's another example. This is if you should open a present or not. So we have our start terminal. Then we go down to a decision rhombus. Is it your birthday? If no, then you're just going to go down to the end. If the answer is yes, then you'll carry out the process of opening a present. Then you'll ask the question, is there more presents? If the answer is yes, you loop back up, and we'll talk more about loops in a couple of weeks. But this loop will continue going until the answer to this question is no, and then you stop. Here's another example, very simple. We have our start terminal, a decision rhombus that asks if the temperature is less than 32 degrees. This is for covering tomatoes in your garden. So if the answer is yes, you will cover your tomatoes because it's going to be cold. If the answer is no, then you'll keep them uncovered, and that goes to the end. So here are a few more examples if you'd like to go through these on your own. This is kind of like a little matching activity that I would do if I was in class with you. But take a moment to pause the video and try to plop in these phrases over here where you think that they belong on the flowchart. And then there is a key on the next slide. So pause the video. So here are the correct answers. So this one is starting with the problem. So rather than just saying start, it has like a problem that needs to be solved here. So your lamp doesn't work. The first thing you have to ask is your lamp plugged in? And if the answer is no, then you plug in your lamp. And then if the answer is yes, you have to check to see if the bulb is burned out, so on and so forth. So as you can see, these are all end terminals, each of these green rectangles, so they don't have to go to some sort of end terminal over here. They just put the process inside an end terminal, and that's fine to do too. Here is another example that you can do on your own, so try to plug in the correct phrases here into the flowchart. And you can pause the video for a second to do that. Here we go. Here are the answers. So this is to cross a street safely. So go ahead and check your answers. You got them right. This is Flowrida, telling you that you did a great job. Here's a few more examples. We're going to skip over here to this one. So this flowchart, I wanted to break it up into pieces just so you can see step by step. So this is the process that an ATM goes through. So we have our start terminal, and then we have a parallelogram. Remember, that's an input-output shape. So you would have to type into the ATM the amount of money that you'd want to withdraw, and then the ATM goes through the process of determining if the funds are available for you to withdraw. Then there's another process during which the ATM deducts that amount from your account. And then the output would be the ATM spitting out the cash. And then we have the stop terminal. Here are a few more examples. If you'd like to create these flowcharts on your own, you are welcome to do so. They're on the next 2 slides here. Those are practice for you to do on your own if you so choose, but those will not be collected at all. Your homework for this week will be the how-to flowchart, and that is going to be in the next tutorial. So you can go ahead and start on that now.